It's a very small room. I don't know why I'm mic'd. But thanks to everyone for attending. We're going to get really, really cozy and intimate in here. We're going to talk about something that's very important to Medidata, and we hope it will also be important to everybody in the industry, which is the Medidata Enterprise Data Store, otherwise known as MEDS. And MEDS is really, as you heard Glenn talk about at some length this morning and in some detail, MEDS is really the backbone of everything that we're doing on the platform. But there are some interesting applications for what does it mean off-platform as well. So we're going to explore some of that. And to tell the story about MEDS, we have to start with data capture. And with data capture, as Medidata's history began, it begins with Rave EDC. So it all starts with that data capture. But as we move on, we have a substantial amount of additional data types that are beginning to flow into our clinical trials. And this is where MEDS comes into play. So MEDS is really the mechanism by which we're capturing omics, imaging, sensor, all these other data types that are not necessarily form-based. These are not things that are coming from investigators, they're not coming from sites. They need to be, it's pure data that's coming into sponsors and CROs and needs to be integrated, cleaned, and made available for submissions. So MEDS is really a place where we can get all study data in a single platform. Now, we're going to talk a little bit about how MEDS is powering the platform today. There's a few things that will hopefully demystify a little bit. I think there's some confusion in terms of, do I have MEDS? Do I need to buy MEDS? Where am I in terms of my own MEDS adoption? So we'll get into some of that. And then we'll also spend in the second half of the presentation, and I'll be joined by Ian Fleming, who is one of the product managers on the MEDS team, to talk about what we're doing to bring all of this non-platform data, so all of this stuff that you're getting from labs, all this stuff that you're getting from sensors, et cetera, into the platform in a nice integrated way for analyses. So to talk about how MEDS is powering the platform today, revisiting this tech stack that you may have seen, Glenn, I think, addressed part of it. Moving from the bottom up, we see where we have all of the data that's coming into the platform. So it starts with Rave EDC. There is a whole bunch of curated data that we have that we're culling from across the platform as well. In the broader Medidata context, we have the commercial side, which is where real-world evidence and that data is flowing through. MEDS and Strata. So MEDS is the clinical data platform. Strata is the commercial data platform. And that is, those are the two means by which we're bringing all of that data together, integrating it, and making it available. We have our analytics layer, where we're processing and enhancing that data, deriving insights from it, calculating metrics, et cetera, and then surfacing that data up to be consumed by applications in either the clinical or the commercial space. So to talk a bit about using this tech stack, and this gets a little bit detailed, so I'll spend a little bit of time on this slide, but how we're applying MEDS today to power a central monitoring use case. So patient profiles, CSA, the cloud-based versions of those tools are all 100% based on the data that's flowing through MEDS. So we start with the Rave EDC data. So that data is native to the platform. So anyone who is on Rave EDC, Rave X, that data is in MEDS. So that's live and active today. We also have labs data, sensor data, other data that we have ingestion capabilities. We currently have some prototype and alpha versions of ingestion capabilities around labs, sensor data, non-Rave EDC data. And we're bringing that data in and integrating it back into what's coming from the EDC. So you have your labs data, you have your EDC information, and that is all in a normalized data structure within MEDS for analysis. We have transformation capabilities that exist within that tech stack. So Glenn, again, referenced some of the different data warehouses, the data stores that we have within the MEDS system. This is where we're standardizing the data. We have SDTM-like transformations of the data, so everything is in a uniform format. So we have that. We also have the as-captured data views. So if you need complete traceability to how the data was captured or how the data was entered, you would have that view of the data as well. We have the ability to calculate metrics and look at derived values. So if you have binary indicators for your data values, so it's 1 or 0, that would be transformed into male, female for gender, for example. So that by the time it's being surfaced up through the applications, you would have good insight into that. We have cross-platform analytics that are going on. So we have benchmarking capabilities that are coming across all of this data. So you can see, what does my enrollment rate look like compared to other enrollment rates, or what do my query rates look like compared to other query rates for similar studies, either within my organization or outside of my organization. And then all of this is being delivered through optimized views. So these are the presentation layers to make sure that whatever we're providing is going to be performant, that it's going to have high availability, that it's really going to be fit for purpose for whatever the different analytical or reporting or application needs would be. So keeping this in the central monitoring, patient profile, CSA world, we have machine learning algorithms that are doing lots of analyses of the data, looking at clusters and patterns of the information, and serving that up in a way that is easy to visualize. So right here, we're still just talking about the data and the data analysis piece. And it's these machine learning algorithms that are basically identifying clusters and behaviors and how different data elements within the study data are related to one another. That information is then serviced up to the application layer. And the application layer is where an end user can come in and interpret the results and then actually take actions. And this loop, if we were to do this all the way through, you identify something that looks like an outlier. You want to raise it as an issue in a data management context. You would have the ability to flag it and then push it back through all of the data management processes and the review processes to make sure that the queries get raised properly, the sites are doing what they need to do to correct the information, that it's being repatriated back into RAVE correctly, and then that ingestion process happens all over again, bringing it back up through MEDS. So that's a bit about how MEDS is powering platform applications today. It's important to talk about MEDS in the context of the tooling that comes with MEDS, because it does have its own set of utilities and its own set of tools. So in this diagram, the top half is all about how you're consuming data. The bottom half is about how you're ingesting data. So I'm going to focus on the top half first, because this is where we're really active today. So today, if you're on RAVE EDC, if you're on cloud administration, you are getting MEDS Reporter out of the box. This is something that is available to everybody. MEDS Reporter today has 36 standard reports. We're going to rapidly grow those list of standard reports. And then sometime in the first half of 2019, we're also going to deliver ad hoc reporting. So you'd have the ability for whatever data that you would have access to in the overall Medidata platform, you would have the ability to generate reports as you see fit. That's an important enhancement that we'll be making. Additionally, bulk extractions. You'll have statistical extracts, so the ability to get in and do SAS extracts for your biostatisticians. And then programmatic access through APIs. So all of this functionality, it's not necessarily here today. We have MEDS Reporter today, which is giving you the standard reports. But through the first half of 2019, you're going to have this complete set of access for everything that's flowing through MEDS. Now, the important thing about this is we're replacing a lot of technology that is a little bit old, a little bit dated, very familiar to you guys, but still in need of upgrading and better maintenance ability. And the important thing about what MEDS is enabling us to do is provide a common architecture from the metadata perspective for how we're doing extraction. So the same technology that we're using for reporting, for extraction, for API access, it's a common and consistent set of technology that we have on the platform. And what that enables us to do is be a lot faster in terms of troubleshooting whatever issues may arise in any of these tools. It'll also make us a lot faster in rolling out enhancements and expanding the capabilities as our clients see fit. So we're excited about that. For end users, this also will provide a common UI experience. So as you're working with the tools, as you're setting up your reports, as you're sharing information across the platform, you would have a common set of tooling, regardless of study, regardless of data type, regardless of need, and that will make it a lot easier on the adoption side as well. So we're excited about that too. On the bottom half, similar type of effort that's going on. The ability to manage multiple types of data, multiple formats of data. So we're starting with labs data, and we're going to roll out omics information. We're going to roll out non-rave EDC. We're going to roll out non-Medidata CTMS. All of this information that is not native to the Medidata platform, we would have the ingestion capabilities to bring that in to meds. We have metadata-driven processing, so we are capturing metadata. Ian will go in a little bit more detail about what we're doing with metadata. We're very excited about this. But the metadata-driven processing is essential to making sure that whatever data we're bringing in that's off-platform actually integrates with the data that is on-platform, so that when you get to the extraction, when you get to the analyses downstream, you actually have the data synced up. You know that the exact day that the lab visit happened, the patient identifiers are all aligned. We know exactly what tests were run and how they're represented in the RAVE data, and then how they're flowing through downstream in the lab files. We're going to have data validation pieces that go along with it. You can schedule ingestion jobs, and there will also be API access to do the ingestion capabilities. And just like what we said on the reporter side, the capabilities, the functionality is using all common architecture, common technology. It improves our support, and it also improves your usability and accessibility. Everything that you see here will be delivered in the first half of 2019. So we're currently doing some alpha ingestion for labs, so that is something that is available today. We have some prototype capabilities to do non-rave EDC, but by the second half you'll have full-blown ingestion and reporting and extraction data access capabilities that'll all be driven by meds for labs, and then we'll continue to add data types throughout the year. Okay. So now that we've talked about how Medidata works on platform, we're going to talk a little bit about what meds means for doing stuff off platform. And really the phrase that comes up time and time again is, how do we have meds provide or serve as the single source of truth for all your clinical data? And I'm going to talk about an event that we had last June, which was the Meds CDR Summit. So clinical data repositories. We've been seeing a lot of interest around clinical data repositories. Every once in a while, we would get sent an RFP. We would look at the requirements that were coming through, and we were saying, geez, you know, we're doing almost all of this already just to satisfy our own platform needs. So the origins of meds was everything that I just described. We need to do this to satisfy our customer base, to make our platform work really well. We need that data backbone that McKinsey was talking about in one of the earlier sessions. And when we look at, do we have an actual CDR, we decided to go off and invite a whole bunch of sponsors to our offices in New York. We cleared out a huge section of our floor. We took over our game room, which really upset a lot of our engineers. And we spent an entire day together talking. And the first part of the day was all sponsors talking with one another. This wasn't, Medidata did present, but only for about an hour and a half of the entire first half of the day. The rest of it was sponsors explaining their trials and tribulations of trying to deal with their own clinical data repository needs. How are they formulating their strategy? What do they view as important? And then we spent the second half of the day doing a design thinking exercise. We actually brought in, you can see Frog is a design company that's based here in New York City. And we had Frog in to go ahead and run a design thinking session where we ideated on what are the number one use cases? Why do you need a CDR? What is really important about having a clinical data repository? And from this summit, we came away with three very clear insights. The first is that everyone wants a very solid foundation. They want the basics of having all of their data in one place so that they can view it. They just want to get, one of the most exciting things that people could talk about was audit trails. That was one of the number one use cases. A lack of data standards was a hugely important piece of this. And this does speak into what Ian's going to talk about with what we're doing with metadata. But a lack of standards and the impediments that it's posing for the interoperability of all of this data. What you're getting from labs, what you're getting from different labs is not necessarily aligning. What they're seeing across all the different systems, what they're getting from CROs, a huge problem that we're hitting upon is all of these different CTMS systems that sponsors need to consume. Everything's coming from all these different CROs. How do they integrate that and bring that together in a uniform way? And then having the traceability of all of that data is so important and such a huge lift. And then lastly, customers are clearly looking for a home for their data that is non-EDC. So everything that's imaging, everything that's omics, everything that's labs, everything that's sensors, all of this information needs to come in a single repository. So when we think about how do we provision data beyond EDC, there's a basic left to right flow. So we have multiple data sources and formats. Medidata does play a significant role in our clients' data availability. But we also know that there's a ton of non-Medidata data out there. And by the way, not just non-Medidata data in the form of labs, omics, et cetera, but also EDC. Critical to everybody. We know that Rave is not the only EDC provider out there. We know that a lot of our customers use other EDCs. They're getting data from CROs that are using other EDCs, so it's important that we have a broader than Medidata view of the data world. And then, of course, clients have their own data warehouse, so there's a bring your own aspect to all of this. So it's important that we have data integration capabilities, data storage capabilities, data extraction capabilities, and then putting a layer of analytics reporting and access on top of it, and then also make it so that clients' own tools, systems, even your own data lakes could potentially draw from this information and make use of it. So this is a very bright graphic. So moving left to right, we have, this is where we're bringing all the data in. Capture is everything we're bringing in on platform. Ingest is everything that's coming outside of that. I'm going to bookend this. I'll get to the middle in a second. Here's all our reporting, extract, access. This is basically the core design of what we're doing with Med. So your real interaction points are going to be on the capture and ingest, the report, extract, and access. This highlighted part in the middle where we're storing all of the master data, where we're mapping the data to standards and getting good semantic understanding of what is contained in that data. That is absolutely essential for us to get to the transformations that are required to power everything that would be required downstream. So here we're talking about transforming the data into SDTM formats, giving you the tools to have that good ability to work with it to create other analysis data sets, derive metrics, get your historical views, do the complete data lineage because you have full traceability of everything and you can go from one representation of the data to another representation of the data, which is so important in any data management workflow. And ultimately, it's all about making sure that the data is fit for purpose. So as we're presenting it, as we're making it available, that it's actually serving the needs that our customers have for clinical trial submissions, data management, and really any other usage on platform or off. So now I'm going to hand it over to Ian Fleming, who is our resident guru on all things metadata.
Can I get that?
Yes, you can.
All right. So this is, just riffing off of what John just said. This slide just shows kind of the process of how exactly we're doing that. So we have EDC data that comes in through Rave. Okay. And third-party data that's actually coming in.
Interesting.
I'm just gonna, every time it's up, I'm going to talk.
Yeah.
Yeah, and then there's the ingestion component that actually happens, and then the transformation piece that actually happens, and the outputs are going to be things like stuff that goes to Med Reporter or any kind of a reporting tool we have and support, and then also custom data sets in SDTM and ADAM that John had talked about. So the way, what do? There we go. So the way that we're going to do that, and I will say that this is a little bit more forward-thinking, and so what we're trying to do with what we're calling the Medidata Knowledge Graph is really to build for the future. We're just in the beginning of stages of building this out, so I can share with you exactly what our thinking is on this and how we're actually planning on working with clients and partners to actually develop this. And in my view, when Glenn was talking this morning about an intelligent data platform, I really view this as kind of the core of that, or the foundational level of that intelligence, right? So, anybody who's familiar with knowledge graphs knows that they're driven by ontologies. It's a slightly different data representation than what we're all used to, like relational stores, tabular schemas, and things like that. But we can represent a lot of different things in it. So the common dictionaries, common medical dictionaries like NCI, SNOMED, MEDRA, things from UMLS, whoever else, in addition to data standards that come from CDISC or actually come from anywhere else. And the data format is actually flexible enough that it allows us to kind of change those over time without harming things that actually happened in the past. Semantically and logically expressive. And what our goal for this knowledge graph is actually have it to be a definitive repository of clinical knowledge and facts for everything that runs through our platform. And that only comes with robust data governance, obviously. So for anyone who's not familiar with knowledge graphs, you use them every day, but you just don't know it, right? And that's kind of the goal for us. Facebook and LinkedIn, these two companies would not exist without knowledge graphs because their entire platforms are built on top of them. Anybody who uses Google, for example, if you were to look up anything online in the past 5 or 6 years, you will notice you get a card over on the right-hand side here. That's actually powered by their knowledge graph. So when you search Google 15 years ago, if you search for David Bowie, you just got a list of links. But Google itself, the search engine, didn't know what David Bowie was. It was just a string of characters that was trying to match to something that was on its platform. But now Google actually has knowledge to know that David Bowie is a person, he's a musician, musicians make songs, they make albums, they're in bands, all these things like that are part of their knowledge graph. And you can see that when you start looking at a lot of these different things, how that graph starts to web out, and you can actually start to see all the things that are related to David Bowie. Additionally, if anybody uses like Siri or Amazon Alexa or Google Home, you're hitting a knowledge graph, right? So if I were to go and ask my Amazon Alexa who fought in the Battle of Waterloo, right? It's going in the back and it's actually hitting a knowledge graph, finding out that entity and finding out who is actually fighting in that battle, right? And that's all powered by their ontology and their knowledge graph. Wikipedia also has, it's not part of actually Wikipedia, it's DBpedia, where someone has actually gone and taken all the structured information on DBpedia and turned it into a giant knowledge graph for information that's on Wikipedia. BBC has a really great soccer ontology or football ontology if you want to look at that. Additionally, for Google, another thing that you can see how this is like a platform level service. If you were to search for restaurants around here, this is a really good restaurant. They have a great burger. I highly recommend it. Wayne knows what I'm talking about. And this is actually a platform level service. So if you search for this, you're going to get the map information. You're going to get the other information. It's all coming from that same knowledge graph, regardless of what Google tool you're actually using. So there's a lot in this slide. I'm not going to go through all of it. Anybody can take a picture and read through it themselves. But essentially, what we view the knowledge graph is it's an enabling technology or enabling capability, right? Just like with all those other services, you don't even know that you're interacting with their knowledge graph. You're just asking a question and you're getting an answer, right? So we really want the metadata platform experience to actually be the same kind of thing. So you just ask a question, you get an answer, right? And so how do we do that? We really view this as being the single source of truth for all information on the platform, concept-based, meta and master data management for anything we have on the platform, as well as analytic and metrics libraries. This one's actually kind of interesting because if we have a singular definition of an analytic, no matter what it is, right? So it's logistic regression or something like that, we can actually have a semantic definition of what logistic regression is. It knows that what the inputs are and the outputs are, and the data types, and you can actually apply that to a lot of different types of data. So you have a canonical definition of what that method is, and you can apply it wherever you need to. Anybody who's worked with semantic technology knows that it's like highly expressive. It's way more expressive than something like a relational schema. Data integration is mapping, and like John said before, if we have the ability to kind of like take data that's flowing into the platform and map it semantically to a common concept, we now can map it to something else that we know also has that same common concept. So if you think about SDTM or ADAM or any of those standard data models, it's basically just a bunch of medical concepts arranged in a certain way in a table, right? And so all we'd be doing is just arranging those concepts in such a way and powering our infrastructure to read off of that and create data in that format or in that structure. Machine learning and artificial intelligence, because of the ability to link all these things together, it's really a boon for those kinds of things because the relationships are already in the data. And then all we're going to be doing is just looking at that information to try to look for patterns. And I'll talk a little bit more about that in a second. And the technology is agile by nature, right? It doesn't actually lock you into rigid schemas or anything like that, so you can actually have a lot of flexibility over time. So here's an example. So let's say that you were starting with a study or something like that, and you knew you actually had to do a venipuncture for a blood test, right? Where would you even start? How do people know what are all the attributes and things that are associated with that? So inside of a graph, essentially you would know that a venipuncture is actually taken at a body location. You can actually define those body locations and how they're linked to this. You have, the method that you're using to extract it, and so the gauge of the needle, for example. And then you can say the types of tests that you're going to be doing. So some of these are individual tests, like HbA1c. Some of these are groups of tests, like a hepatic function lab panel or something like that. And you can actually, specify which things are, required and which ones are optional. So when someone is actually creating a CRF or a protocol or something like that, you can say, okay, you're doing venipuncture. These are the types of things that are required when you're doing a venipuncture. These are the things that are optional, right? In addition to that, we can say that hepatic function is made up of a bunch of different tests. Again, some are optional, some are required. And you can also see that like blood glucose is actually uses a certain type of unit, right? And some of these units are acceptable and some are not. And then when you look at some of the other tests here, you can see that bilirubin, for example, is actually looking at milligrams per deciliter, and it's the same canonical definition of milligrams per deciliter as blood glucose is using, right? So we're not having that unit be all over the platform with kind of lots of different definitions and things like that. We have a canonical place where we can always go to find that. And so if we were to, and also another thing here is the conversions between units. Those can also be encoded into the graph, right? So if I'm transferring between milligrams per deciliter to grams per deciliter, that algorithm actually can be encoded inside of the knowledge graph, and you just use it whenever you're doing that conversion. Again, canonical definitions. We can also link out to other dictionaries. So for example, venipuncture has these other concepts in these other dictionaries like CPT or MESH or MEDRA or SNOMED. We start with SNOMED. Or NCI terminology or whatever that we can actually link into the graph as well. So for example, if this is what you decided you were going to be doing for your particular study and you encoded this into your protocol, what we could then do is actually code these individual values into STTM variables, right? So you see that, for example, the bilirubin actually codes into lab test and lab test code. The milligrams per deciliter codes into the unit, and the cephalic vein and the 25 gauge needle is also encoded into method. And we can actually encode all that into the knowledge graph as well. Because all we're really doing is just plucking these concepts off and just making a data structure out of them that contains those concepts. And they're all part of the lab domain. That comes from NCI, actually. So now for lofty statements. Our goal is to be the definitive source of clinical knowledge in life sciences, right? And so that is a tremendously lofty goal. It's going to take a long time, right? And so you're probably saying, like, how the hell are we going to do that? So this is our thinking on this at the moment, so how we're actually going to do this, right? I don't think we're under any impression that we are so smart and intelligent and great that we're just going to like do all of this on our own and then just present it to you and expect you guys to agree with it, right? So what we really want to do is we want to take this in tiers. So we want to start first with what we know to be fact, right? So for example, blood pressure is made up of diastolic blood pressure and systolic blood pressure. That's a medical fact, right? I can talk to any medical doctor pretty much anywhere in the world and they can all agree on that. So that becomes something we can structure and put as a fact in the knowledge graph, right? And it's also a driver of that validity and trust. Outside of that, we have what we're calling semi-structured, right? These are things that we have an idea on or things that we think to be true, but we can't necessarily be sure, and we want to actually work with our users and with our clients to make sure that we can move that towards the center so that it actually becomes fact, right? And what we can do there is we can actually use AI and machine learning to actually provide recommendations for when you're in this layer, you actually see something and we say, well, we think you should be using this, and please confirm for me whether that is what you actually want to do or if you want to do something else. And then the last layer, my animation, is what we're calling unstructured, right? So this is a playground where you get access to all the entities that are in the entire knowledge graph, and you get to link them together in whatever you want. You also get the ability to define your own concepts, right? It could be that when you are at a client and you are defining a whole set of standards or something like that, you'd be using most of this layer. And what we would be doing in the background is actually just like pattern matching on that information to try to move it closer to the center, right? So all that unstructured stuff, you can talk about cutting edge science, whatever you want to say is actually happening in the unstructured layer. the goal for us is really to take that information and those relationships and those facts and move them closer to the center. And when they're in the center, then they become like publicly available facts for everyone, right? And we really want to work with partners to actually make sure that we have the right user experience and everything on top of this to help us move that information towards the center.
Oh, okay. Yep. This is me. This is just a very simple timeline, but this is really the conclusion, and we're going to have some Q&A, and the screen is really not cooperating. I was very impressed that it was very cooperative through all of Ian's animation. But basically, this is saying, going back to last year, we were thinking we're building meds for Medidata. We saw some interesting overlap between what the market was asking for CDR purposes. We went off, we had the summit, and now going forward, we're looking at not just having meds for powering metadata, but also how it can fit in with the clinical data repository strategy amongst our clients. We are extremely open to conversation and collaboration because we realize the magnitude of the challenge and the problem that we're trying to solve. The key element, again, going back to those extremely brightly colored metadata and transformation layers in the middle, that really is the key thing to making all of this work. And we're very much open to working with our clients on that. So that concludes the presentation. Are there questions? All right, thank you. 10 minutes for questions. Oh, my mic's back.
Quick one. So do you see that at some point the data from the CTMS, let's say the data from the DTMF, everything will go to part of
Correct. Yes.
The second question, would you say that the current ways of getting the data out, like the direct web services and the ODM adapter, these are somewhat outdated and those are going to be deprecated and retired and replaced with the new extraction tools from Mets?
Okay, so I'll repeat the question. So the first was basically everything on the platform: eTMF. What were the other examples? CTMS, RTSM, everything that would be on platform. Whether or not that's going to be in meds, the answer to that is yes. The second question was when you start looking at Rave Web Services, ODM adapter, et cetera. So all these tools that we have built around Rave and whether or not they will ultimately be replaced by what we're seeing in meds, the answer to that is also yes. We want to make everyone comfortable. We're not just saying, oh, we launched version 1 of Meds Extractor, therefore you no longer need ODM adapter. So we will continue to support, we will continue to migrate, but the tools going forward into the future will definitely be the Meds Extractor, Meds Reporter, Meds Ingester. We'll be replacing things like the Rave 360 reports and batch uploader and ODM adapter, and those types of tools will be replaced by those. So all of we're still maintaining those. We're still supporting our customers on that. It's still going to be a viable path for people for a while. So we understand that there's going to be a bit of a transition, but the whole future state technology is going to be what we're putting out in the first half of 2019.
If I understood it right, it's not only a question of how do you get the data out of Mets. Maybe the CTMS is going to take a new look, or it's going to be what do you call redone or CTMS 2.0 kind of thing.
Correct.
Something happens to eTMF and
potentially yes. We'd have to get into the specifics of each of those, but from a basic data element standpoint and from a access standpoint, we would want to make sure that it's progress, not regress. All right. So there's a question. Yeah.
When we are talking about the metadata, we talked about the structured data, unstructured data, and semi-structured data. If I heard you correctly, you wanted to bring the unstructured and semi-structured into some kind of structured.
There's a semantic problem here, and I'm not talking about data. I'm actually talking about knowledge, right? So I'm semi-structured knowledge, which is different than structured, unstructured data, right? Yeah.
What I was confused about is in our business we have documents which are totally unstructured that are related to the data, right? But you should be able to link them with the semantic knowledge.
Sure.
So that's where I was confused about.
So I think, the thing to think about is that like the unstructured and stuff that is on that graph, I'm not talking about data. I'm not talking about free text. That's not what I'm talking about, right? And so that's more saying like it's an unstructured area for people to create knowledge, right? And so there is absolutely a place for what you're talking about, right? And there are tool sets on the market now where you can actually do semantic search and things like that, where you can ingest a whole text file and actually do entity recognition and basically turn it into a graph. That exists, and that is absolutely going to be a thing that we're going to have to support in the future with something like this.
And just to speak a little bit to that on the roadmap, so we definitely will have the ability to ingest and store the unstructured data at a minimum in the relatively near term. It'll be a bit longer term, I think, before we actually have that fully integrated in that way. When we start talking about things like images and those types, that would be, we have a different mechanism for dealing with that, because there's the actual images themselves, and there's the data about the images and whatnot. Yeah, so that is something that would be more on our near term roadmap. But if we're just talking about a document of any type, we will have the ability to bring that. It would look a little bit more like a co-location. We would understand what study it was related to. We might even get some metadata about the visit or a subject, but whether or not we'd be able to read that in as some insight that's relevant to the study, that's probably going to be a little bit further out in the roadmap.
One more question. We're talking about the platform and the data, right? Where we have some problems is the amount of the data. What kind of amount of the data that we are talking about? Petabytes?
Yes.
Zettabytes?
All as much as it takes. All the above. All the above. Yeah. I mean, the good news is that technologically, the volume of data that we would need to support for clinical trials, I think others in other industries have proven that this is very doable. And we're working off of modern cloud-based architecture. There's definitely, and just to level set expectations, as we start bringing in this additional data, that's, there's no rave application that you've paid for, just talking about it commercially. There will definitely be some commercial consideration because storage does not come for free. And all of that good integration and interoperability, is purely value add. So one of the interesting components about Medidata, who Medidata is, and Meds, and how Meds is architected, it really will be a different procurement model from what is typically done in the CDR space today. Right now, CDR space looks very much like an IT solution, acquisition. It's a custom build. Maybe there's some off-the-shelf tooling, but everything has to be configured specifically for a customer. We're looking at a multi-tenant, cloud-based infrastructure. So this is really starting to get into platform as a service, as opposed to what you may be used to, and the economics around that are going to be different. We think it'll be more beneficial to the market. We've got a lot of questions in three. I'm going to go right to left. So yes.
Actually, I just have two questions. Remind me what the metadata CTMS was going to be part of that. And then the second question is, as you roll out more systems, are you basically rolling them in where they work with all versions of that system, like metadata, or is it a certain version for?
So sorry, the second part of the question.
Well, let's say you roll metadata CTMS on whatever
Correct.
date. Is it any version of metadata CTMS, or is it?
Got it. Yeah. No. And great question. So the new, as we're building out the new CTMS solution, it's the cloud, not the cloud. Sorry, the platform. Cloud admin was where I was going with that, but it's the platform level CTMS. So it is that version that will be powered by Meds. So as you can imagine, again, the flip side of having all of that common technology is it's a new technology, right? So we are working empowering CTMS off of the new technology. So it'll only be the new version of CTMS. That said, we're going to make Meds as interoperable as possible. So it's, I hate to be like non-committal, but it's a little TBD in terms of how we would interact with other systems.
It's kind of like that with all the products then. It's going to be.
Correct. Okay. There was, yes.
I wonder if you could just talk a little bit more about the lab data ingestion. Specifically, right now we have a separate ETL for the software process that we use. Are you envisioning something
Correct. So everything is UI based. Well, actually, I shouldn't say everything. It's UI based. It's UI based direct file upload. It's UI based automatic upload, and then you have just full API access as well. So if you have your own program where you're landing the data and you want to push it into Meds, you'd have an interface to do that, just pure software to software. We also have a UI where the UI is actually deeply integrated with protocol elements and form elements. So you would have an idea of the study and the visit and the data elements that are going to be captured on each, and then also the specification of the file. And then you set up that structure, and then you can start loading the data automatically. And then everything happens in the back end. It's like drag and drop, upload file.
Yeah, the one big difference. Are you putting data into the lab data into Rave right now, or are you elsewhere? Okay. Then my comment makes no sense.
So yes.
So Meds really sounds like it's going to be a game changer for sponsors to integrate all of their data. How do you envision CROs leveraging a system like Meds?
Sure. Well, first off, CROs, as you heard, CROs this morning, are actively using the Medidata platform. So first off, they're already using it in that way. In terms of adding the additional data, I mean, I think CROs have similar types of issues and capabilities around how they're managing the data workflows. So those tools and that tooling would be available for CROs. And it fits neatly in terms of how we're already enabling CROs on Rave and Rave EDC and our strategic monitoring suite and everything else that's on platform. I think that this would fit very similarly. We're kind of out of time, which I think means we actually are out of time.